Hey everybody, how's it going? In this video, we're going to be installing these really cool prefabricated insulated wall panels to my timber frame structure. These are called SIPs, which stand for Structural Insulated Panels. And I know it's been a really long time, like 10 months since the last video, and I want to apologize to everyone who's been following along, but I'm ready to get back in the saddle, get all these videos published. So let's jump into this video on installing these really cool things called SIPs. And big thank you to Insulspan for sponsoring this video. All right, good morning. The SIPs are on their way right now. Kind of a nerve-wracking day. Hopefully we can get them off the semi with the tractor. You know, we made it through with all the timbers, but who knows? I was supposed to get a telehandler by today, but I don't think it'll be here this morning at least. Maybe it'll be here tomorrow. But we're gonna try to make it happen with the old tractor again. Luckily they have fork extensions that will help because some of these pieces are like 8 feet wide. So it's gonna be pretty intense. Probably might need that crowbar thing. There's the easy batch. So I got a total of 2 semi-trailer loads full of the SIPs for my house. The first load I only had my tractor and the unloading went fairly smooth, except for one of the panels did slide off my forks and broke the tip off, which was really frustrating at the time, but I was able to repair that. So that's all good. And these things were super slippery on the forks. So if I were to do this again, I would temporarily glue down some type of rubber strips to the forks to help them grip better. And for the second semi-load, I had the telehandler on hand, and those can level their forks out, which made it a lot easier. Plus, they can lift a heck of a lot more than my tractor. Another challenge of unloading was trying to organize and stack the panels in the order that I would need them for the house. They came on the semis optimized for transport, and because of that, they were shuffled all over the place. Well, it's a really big day today. We're going to be installing our first SIPs on the house. The frame is completely done, and we're going around and putting shims all around the frame so that later on, after the SIPs are on, the house is dried in, I can go and install my drywall between that little gap that will make up right here. I'll be able to slide my drywall in from the inside on the walls. Ideally, if you're a really good crew, like Shelter Institute does, they'll install all the drywall first and then put the SIPs on top of that. And it's an easier and better way to do it, but this is our first time ever doing this, and I just didn't want to fiddle around with all that extra stuff, especially when I got friends volunteering and helping, stuff like that. So one of the representatives from Insulspan, which is the SIP company that I've been working with, awesome group. He's coming out here. It's about a 2-hour drive to help us get off on the right foot. I've really been studying the process and I have a pretty good understanding. I think we'll be okay, but it's gonna be really nice that they're coming out to help, and it just says a lot about the company. I wanted to show you real quick the details of how these SIPs work. So you have your insulated panel, which is OSB, your EPS foam, and another skin of OSB, and that will sit on your sill plate here. So I have a 2x6 conventional sill plate here, and then your regular pressure treated underneath it, and your SIP will slide down over top of that. Now this is a piece that I just cut out, but the ones from the factory are cut so it's nice and tight joint right there. I'll add a bead of sealant to the middle and a bead of sealant to each edge to give a really, really nice airtight sealed structure when it's all said and done. And then you'll you'll nail all along the bottom flange with 8-penny nails, and then you'll screw through the SIP with big 9-inch, 10-inch, whatever it calls for, screws big structural screws that go through the SIP into the timber and bury into the timber about 2-3 inches, and those are every 12 inches all through the whole structure. So not only do you get a continuous insulated thermal envelope on your house, unlike a stick-built house where there's 2x4, 2x6 studs, there are thermal breaks every 16 inches. You have a continuous foam insulation all the way around the house, and they're really structurally strong. They're stronger than conventional stick-built houses as well. So, and you have the timber frame underneath. So it's just a really awesome way to build. It's kind of expensive up front, but you save a lot in the labor because it should go really quick if you know what you're doing. Compared to stick framing and putting all the batting and stuff in. But really excited. It's a pretty big day. Hopefully it goes well. I don't think this is that like inside corner wall, so I don't think that
we could pre-drill it.
If you know you're not gonna need to.
Yeah, I don't think this one does. I know there's marks on the underside for our electrical.
Oh yeah.
On the inside ones they mark it all, which is a really nice little thing they do. All right, so yeah, sealing is like super important on all this.
Pre-cut the board.
Wouldn't hurt. Now I believe this one goes all the way to the ground because I left it inlet, so big old. Now where's the best place to put the bead at? Like in the middle or towards the corner?
I mean, it
doesn't really matter. I know it'll push it a little bit.
Yeah.
Okay. I'll go get the other gun prepped too.
You have to do top and bottom?
Yeah.
And you know, like I said, once you kind of get in the rhythm, you'll find where, you know, the ground guy only does one side because it's easier for the guy that's on the floor to do the other side, kind of thing. So that's what we always do.
We prep the panels as much as possible while on the ground, and we add sealant to all the joints, which is another reason why SIP houses are so efficient. It's because they're extremely airtight. And there are a couple different ways to attach the SIPs together, depending on what the engineers call for in the plans, either with conventional lumber or what is called splines. The 2x6 conventional lumber is used where extra structural rigidity is needed. And the splines, which are basically long, thin strips of SIP panel, are used when there isn't a need for extra structural support. And when you use those, you eliminate any thermal bridging that you get when you're using conventional lumber. I got my SIPs from a company called Insulspan, who is the sponsor of this video. And SIPs, again, stands for Structural Insulated Panel, and they're a dream match for a timber frame structure because they can very quickly enclose the entire timber frame in a perfect, insulated, airtight envelope with very little thermal bridging, and all your window and door openings are already cut into the panels. The entire beautiful timber frame structure is going to remain fully visible in all its glory on the inside when your house is all done. Now there are several other ways to enclose a timber frame. You can build essentially an entire stick-built house around your timber frame and then insulate that, or you can infill stick-built between your timber walls, and then there's a couple other ways as well. Now the downside with SIPs are they are the most expensive upfront cost compared to the other methods. But if you factor in labor cost and the speed in which you can assemble these and the long-term energy cost savings, they're going to more than pay for themselves in the end. So I actually got a chance to go visit the Insulspan factory where the panels are made, and I wanted to show you real quick how these things are made because I thought it was really cool and very interesting. The first step is they take giant 8-foot by 24 sheets of OSB. I didn't even know they made OSB that big, and they glue them to the top and bottom of rigid EPS foam. And the thickness of the foam depends on the plans and what these panels are going to be used for. So for here in Michigan, we use 6-inch foam for the walls and 10-inch foam for the roofs. Another cool thing about the SIPs is that they core out all the electrical wire chases in the foam so that after all the walls are installed, the electricians can run all the wires within the walls. And I'm actually past that point in the house build, and I can tell you that the electricians were pleasantly surprised at how well that actually worked. The wire chases all lined up, worked perfectly well, and they didn't have any problems at all. After the glue is applied to the top and bottom skins of the OSB, the panels are put into a heated press to quickly cure the glue. And another awesome thing about SIPs is how strong they actually are. The walls have the same kind of strength characteristics as I-beams do with how they resist compression and tensile forces, and that's why they're called structural insulated panels, and that's why they can be used for walls and roofs and build entire houses out of just those. Next, the full 8-foot by 24-foot panel is going to go into this giant CNC machine where it cuts the panels to the exact size that they need to be, and whatever window or door openings or any other special details need to get cut into it. I was super impressed when assembling these panels on the house and how perfectly everything actually lined up and went together. The panels were dead on, and I didn't have to alter even one of the panels. After the panels are cut down to size, the foam along edges is removed to accommodate lumber or splines where needed. They do this with these really cool custom-made angle grinders that have these special paddle bits. Well, it's time to get back to installing these walls. Big thank you to Insulspan for sponsoring this video. I'll put a link on how to contact them down in the description.
Has there been adhesive added to these?
I don't see any on the panel.
Okay. I'm gonna add a bunch real quick. Hold on. Oh my gosh. Got it all over my jacket. Okay. All right, let me hand that to you. That sucks.
So I bought this nice new Milwaukee heated coat recently because it's January here in Michigan, and within the first hour I got this SIP sealant stuff on it and ruined it. And by the end of this project, this coat was covered in that SIP sealant. Most of my pants had been ruined. It was on my boots, my tools, my tool bag, had even gotten into my beard and mouth at one point. So be warned not to wear nice clothing if you plan on using SIPs. At the beginning of the video, I mentioned it's been about 10 months since my last video, and one of the main reasons for that is because I started my own woodworking tool company last year called Temple Tool Co. These are premium Japanese hand tools that I spend a lot of time fine-tuning and adapting to better suit us Western woodworkers. And with it being the holidays and it being our 1-year anniversary, we're running a 20% discount on all of our tools for the next week. So I wanted to share that with you. You can find a link to that down in the description and use code TT20 at checkout. And thank you so much, everyone, for all the love and support with Temple Tool.
All right, day one went really well. Yesterday we got the front of this wing and almost this entire side installed. There's a lot of screws. We'll go back and screw it securely, all our big long 9-inch screws. But we're at day 2 now, the next day, so we got a bunch more to hopefully accomplish. Hopefully the front of the house, at least one of those sections, and then we might put the basket on the telehandler and go around and screw it, everything that we have done, really secure it before moving on to any other sections. But off to a good start. Hopefully everything remains safe and good and productive today. Watch that pipe on the, okay. Just bring it straight at me.
We had like a 1/4 inch space, I think, by my measurement.
Okay. That's what I tried to shoot for. We weren't supposed to drill through this side, I don't think. There we go. Come on. But there's this stuff called RMR 86.
Yeah, I used it in my attic.
Yeah. How's that gap looking right here now?
Oh, it's going. Oh, dude, you got half of it. Got almost.
Shoot a couple of these. All right, so we built this whole section on the ground here. And I think it was a good idea. I think it's gonna make it a lot easier than trying to build the sections while it's up in the air. There's a lot of 2x6 support stuff going on here. So hopefully we can get it lifted up without any problems. It's gonna be quite the pretty heavy piece, so. Good thing I'm wearing a hard hat, Cody. I just domed myself on that boom arm. So for here, we need a full-length piece to go from foam to foam, and then
This mini one or stand up?
no, we just
Which
go
one are we
straight.
doing?
We're doing this piece right here. We're gonna connect these guys to it, and then slide it over, and then we'll put that one right on top of everything. I don't know what I'm gonna hit it with. Hit on it. I'll hit it from, I got it. I'll put it in the windowsill. Let me try from the windowsill first. It's working on the bottom. I don't know if the top's going in.
One thing that Insulspan offers that I didn't take advantage of are their lumber packs and ready to assemble packs. So at their factory, they can cut all the pieces of 2x material that you need to assemble them. And they can also offer a package where they install those at the factory for you. They tell you exactly how much lumber you need. So I just purchased the lumber to save myself some extra money. But with the amount of time, measurement, the sealant, the installation, all the nails. I think it probably would have been worth that extra cost to have them cut it and assemble it. I didn't really have the extra money at the time, but if I did, I think that would have been money well spent. Well, hold off on these ones. We're going to add a piece right here as well. But I just want to double check to make sure that. Like I mentioned earlier, I was so impressed at how well all these panels perfectly fit to my timber frame. There was no need for adjusting these at all. Everything locked together beautifully. They're basically like a giant Lego set for your house. I was really intimidated going into this project, having never worked with SIPs before. They're really expensive. I didn't want to screw anything up. It's getting cold and winter time, but again, I just couldn't be more impressed at how well these went together, and I would definitely build with SIPs again. One of the unfair reputations that SIPs have is that the roofs are prone to rotting, and this is mainly because back in the 90s up in Juneau, Alaska, where it is extremely wet and moist, several houses that were built with SIPs had problems with their roofs rotting. And the main reason is that they weren't properly sealed from the inside. When you're building with SIPs, you really have to control moisture movement. So here in Michigan, where it is a mixed climate or a warming climate, which means that we're doing a lot of heating during the winter months. And so we have warm, moist air on the inside. And if my inside roof seams aren't sealed properly, then moist air can get pushed into those cracks. And when they reach the cold exterior of the SIP, where the roof panels are, then they'll condensate and that moisture will just sit there and it can't really escape. That's why you'll see on the edges of my gables those flapping pieces of tape. That is a vapor-proof tape that goes on all your interior, especially roof seams. You can put them on the wall seams as well. So it's really important, just like any kind of building, that you properly think about moisture control, air and moisture movement, and if you prepare for those and seal those properly, you have nothing to worry about. Well, everyone, thanks so much for sticking around and watching. In the next video, we're going to be installing the roof panels, which gets a little more difficult. That's a 12-12 pitch roof, and they're much bigger. It's going to be a lot of fun. We'll see you then.